for piecewise by hand. And I told you we'd come back and talk about the calculator process for that. So I'm going to use this example at the top that's pre-printed here. And as we go through the steps, this space here is for you to write in your own words, however is going to help you remember the keystrokes, what you need to know in the calculator. Okay, so the first thing you're going to do is you are going to go to y equals, and you're going to type in your equation divided by the restriction. The easiest way to do that is to use the numerator denominator feature we talked about in the scavenger hunt on Friday. So you're going to go to alpha y equals enter, and that gives you the numerator denominator. Okay, that makes it easier than having to use lots of sets of parentheses. You're less likely to make a mistake this way. Okay, so again, that was alpha y equals enter to get the numerator over denominator fraction. So in the numerator is your function. Okay, so I'm going to split this screen here. Okay, so the first piece of our function is 2x. So we'll type in 2x. Okay, and then in the denominator, you put the restriction. Okay, in this case, it's x is less than 2. Okay, right here. So I'm going to type in x. Now, to get your inequality symbols, okay, this is under the test menu here. So you're going to have to hit second math. So you go second math to get your inequalities. Okay, and you can, we're typing in less than, so you can scroll down and hit enter, or you can just type in the 5 for less than. So x is less than, and in this case, it's 2. Okay, so that's my first piece. Then I'm going to go to y2 to type in the second piece. So again, I'm going to go alpha y equals enter to get the fraction. I'm going to put the function in the numerator, so x minus 1. And in the denominator, I'm going to put the restriction. So x, and this time it's greater than or equal to. So again, I hit second math, and then greater than or equal to is the fourth option. So I'm going to hit 4, 2. If you have one of the color TIs, whatever versions those are, you can set these colors to whatever you want by scrolling over to where it's highlighted. Here, and if you hit enter, you'll get the option to change the color, and you can use the arrow to change your color. And they have lots of different options there. And then you just go down to OK. You can also change the line there to like shading above or below the line, or having a dashed or dotted line, but we don't need to worry about that today. Okay, so I'm going to hit OK. All right, so once you have all of your pieces in, each piece is in its own separate y equals, okay, you can go to your graph. And it's going to graph those pieces. So you can see this graph in the calculator matches this one here. Now, if I want to check exactly to see if it matches, I could change this window. So I could come here and change this window setting. Make that graph a little bigger. I need to see all the keystrokes. So if I go to window and I want to match this one goes from -5 to 5 on the X and Y. So I'm going to change it to -5 to 5 so that you can see it matches exactly. Go back to the graph. Now, what is one thing that you notice that's different about this than the one that's printed on the paper? It doesn't have the points. It doesn't have a closed circle or an open circle, and it won't. Your calculator won't graph the endpoints. Okay. It goes off the graph, indicating that it continues, but where it stops, it will not have an open or closed circle. So you still do have to pay close attention to your inequalities here to know if there's not an or equal, it should be an open circle. If there is an or equal, there should be a solid circle. Is everybody good with that? But it will show the pieces of the graphs, the curves or the lines, whatever the case may be. Okay, but you still have to make sure that you pay attention to whether there should be a open or closed circle. Okay, so real quick, I'm just going to add in here. Okay, so we hit alpha y equals enter to get the numerator over denominator. And then we hit the second map to get the inequalities. Okay, so that's what we need to be able to find. So now like the actual steps, we type each piece of the piecewise into its own y equals. Putting the equation or the function in the numerator. And the restriction or domain, however you want to word that, in the denominator. Okay, now, if you forever forget, this is being recorded. This video is going to be on your It's Learning. You can go back and watch and see my calculator on the screen and see how I did it again if you've forgotten. Okay, those instructions clear to everybody? Does that make sense? Okay, you may want to add the little note that the calculator does not plot open or closed points. So just know you're going to have to know to do that by hand. Okay. So we're going to go down here. We went over number 1. We did it all by hand. We got the key features. And then we did number 2 by hand, but we didn't do this part that said check with the TI-84 because we hadn't talked about it yet. So I do want to go ahead and do that now that we've gone over those steps. My screen will move. Okay, so I'm going to go back because this one is a little unique because this middle piece, the restriction is on both sides, right? Okay, there's 2 inequalities. So how we type this in is different than what we just did up at the top. Okay, so pay close attention. We're going to clear out what we have and start over. So these are new pieces. So the first, and I'm going to go ahead and match this because I'm going to pull the screenshot over. So let me match my colors. So we did purple, green, and then blue. Or purple? Might not be purple. You know, I may have to use that pink, that magenta. Okay. Green is good. And then I'm going to make this one blue. Okay. All right, so what's the first thing I do? To type in my piece? Alpha y equals enter gives me my numerator over denominator. And in the numerator, I put the equation, so x minus 5. In the denominator, I put the restriction, x is less than or equal to 0. How do I get the inequality again? Second math. Okay, and this one is less than or equal, so it is the sixth option down. Okay, 0. Okay, and I'm going to go ahead and skip down to the third one and enter it. I'm going to come back to the second one because that's the special case. So I'm going to go alpha y equals enter. Now, my actual function is a fraction. You can put a fraction in a fraction. It's fine in y equals. It'll know what you're doing. So I'm going to hit, once I'm in the numerator, I'm going to hit alpha y equals enter again. And I'm going to have a fraction in the numerator. And that's going to be my 2 over x. And then in that denominator, I'm going to have my restriction x is greater than 2. Okay. Now I'm going to come back to that middle piece because here's where it gets a little confusing. So I'm going to do my alpha y equals enter to get the fraction. I'm going to put x cubed as my function in the numerator. But in the denominator, you cannot put your variable in between the two inequalities for some reason. It won't read it correctly. So you have to write it as two separate inequalities with and in between. So we need to write that, oops. Come on. All right. We need to why? I don't know what's going on with my paper. It scrolled up on me. We need to write that x is greater than 0 and x is less than or equal to 2. So what that looks like in the calculator, I'm going to write x is greater than 0 first. So x is greater than 0. Now the and is under that same menu, so second math, but you have to scroll to the right one tab. And then you, under where logic is highlighted, you see and. Okay, so we're going to say and. And then we're going to type in x is less than or equal to 2. So the denominator looks a bit different than it does on our paper. So I'm actually going to take a quick, I'm going to make that bigger and do a little screenshot of that so I can have that posted in the notes online. Go back to second math again, just like we did to get the inequalities, but scroll to the right so that logic is highlighted. And then and should be the first thing there. Oh, not enough. Okay, so I'm going to copy this to our notes here. Down here by the problem it goes with. All right, so we're checking this in our calculator. This is what it looks like plugged in. Okay, and I want you to highlight or do something to make a note of how this was a different way typing in the restriction. Okay, that's how you had to type that in. Okay, so I want you to make a note somewhere of that so that you remember. Okay, so that's how it's plugged in the calculator. Okay, and I'm going to make a note where to get and. You still go to second math, but then you arrow to the right, and then it's the first option. It's number 1 there. Does that make sense to everybody? Second math, right, and then it's the very first thing to get that and right there. So far, so good? Mm-hmm.
Does the always have to go first?
Does the what?
The X like on the bottom.
You know, I haven't tried it the other way. You could try putting like 0 is greater than or equal to X here instead of X is less than or.
2 is greater than.
You did, and it worked? Okay, so it works either way. Good. Good to know. I just, my habit is to always put the variable first, but good to know it works with the number first. Okay, so let's look at that graph. This window on our notes was -10 to +10. So remember on your calculator, if you have changed your window and you want it to go back to normal, do you remember the keystrokes to do that? You can go to window and individually type in your maximums and minimums, but there's a quick way to go back to that -10 to +10. Does anybody remember it? It's zoom, this middle button at the top, zoom 6. See, the 6th one says standard. So hit zoom 6 and it will take you back to the -10 to +10 on your X and Y. So now we can see all 3 of those pieces. Okay, so again, I'm going to get a little screen grab of that to put in our notes. Man, there's a huge delay today. I don't know what's going on with this. All right, so let's put that some stuff back up here. Smaller. Oh my gosh. Come on, Word. Wheel. Man, it's moved all our stuff around. So absolute value, that next one that we're going to check has an absolute value. There were, when we did that scavenger hunt on, oh, there's 2 of them. That's why. Rid of that one. That scavenger hunt we did, we went through, I believe, 3 different ways to get absolute value. So does anybody remember those? No? I don't know why all this highlighting I did is moved down here. Let me move this up. This is a go. Just get rid of that for now. I don't know why our arrow is down there. What in the world? This. Oh, guys, sorry. This is being a pain in the butt. Bring this graph back down and bring this one up. Okay, finally. All right, so you can see in the calculator what we got is very comparable to what we drew. The only difference it being those circles, those open or closed points. Okay, so at the end of the blue curve, okay, you can add the arrow and you can add the open circle. Okay, and at the end of the green one, there should have been an open circle here at the origin. Okay, and then we said it was a solid point at the top, right? So you could put a solid point there. Okay, and then on the purple, pink, I guess, whatever it is now, it was a solid point. It was included here, and then that was an arrow. Okay. Do y'all feel somewhat comfortable with plugging these into the calculator, how you get it to restrict the domain for each piece? Okay. So you were tasked yesterday with trying number 3. I asked y'all to try it by hand, so I'm not going to do it by hand and in the calculator. I'm just going to plug this into the calculator, and we're going to see what that should have come out looking like. Put this back where it goes. Okay. Erase these marks. Okay, maybe those marks won't erase. I don't know what's happening. Okay. So good question here. Oh, and my equation looks all funny. If I move this, if it makes a difference. It does not. Move up there. No. Down there. That's a little better. Okay. So the question is, how do I type in this absolute value into the calculator? So we're going to go back in, split screen here. And you are going to clear out, and you don't have to completely clear out if you want to leave the fractions there. If you go into like your numerator or denominator and just hit clear, it'll keep the fact that it's a fraction there, and you can just retype your numerator and denominator. So if you want to do that, you can. Okay, so piece 1 is a quadratic. So this one should have been a parabola shape. It's shifted where? What is that? Yeah, that +6 on the inside shifts it left 6. So what the vertex of your parabola that's normally at the origin would actually be at -6, 0. But we don't want to see the entire graph. We only want to see the portion where x is less than -5. Also, did I mention the typo yesterday? Did I have you fix these inequalities? Okay, so double check if you didn't fix that yesterday that your inequalities match mine, because there was a typo on the printed one. Okay, so we want this to be x is less than, that is the 5th option down, -5. And again, make sure you're using -5, not -5. You'll get errors when you use minus instead of negative in places. Okay, and then we have a constant at 7. So that's just going to be a horizontal line at y equals 7, but only from x is -5 to 2. And so again, this is one where we have to split it up. So we're going to say x is greater than or equal to -5, and x is less than or equal to 2. All right, so here we are, ready for that absolute value. There were 3 methods on that TI-84 scavenger hunt that we discussed. What was one of the ways to get absolute value? Does anybody remember? One of them was through one of the F1, the function shortcuts in green, that F1, F2. One of them was up there. Okay, if anybody remembers where that was, and you can explore if you don't. One of them is under the math menu. Okay, so that's probably the most common one is people just go click on math and scroll right to the number, and absolute value is the first option. Okay, so if you need to make a side note of that as we're going through this, you can. That was math, right, and then it's the first thing there is your absolute value bars. So then it's 4 minus x. And then that restriction is x is greater than 2. All right, so we've got all 3 pieces in with the restrictions. I think we're good to go. Again, let me graph that. So this is the piece of the parabola to the left of where x is -5. This is the constant at 7 from -5 to 2. And this is the piece of the absolute value function from where x is 2 to infinity. Is this making sense to everybody? Y'all feel okay about piecewise? Syntax, that is how you typed it. So go to your y equals and show me your calculator. I can see if I see an obvious error in yours. Go back to, I have it typed in. We'll double check to compare. Is your syntax also? So we'll click down arrow, go to. Oh, it's highlighting your minus sign. So I think you might have used minus instead of negative here on yours. Because when I went go to, it highlighted that negative. So make sure you're using the negative button and not the minus button. Let me see what the error is on this one. Nope, I think it's the same issue on yours. For the second one, it's highlighting here. I think you used minus instead of negative. So change that to a negative and then see if that graphs. Did that work for you, Austin? Okay. All right, so it is important that you use negatives and not minuses because it'll give you a syntax error. But so just let me show that to you, might as well, so that everybody sees that. So for instance here, if instead of a -5, if I had typed -5, when I go to graph this, when it's trying to graph that first piece, this is the error that they're getting. Don't just quit. Go and see what the error is so you know. So go to, and it's highlighting where the mistake is. So, oh, I accidentally used a minus. Let me change that to a negative. Okay, and then you can see if you didn't make that mistake until down here in the second piece, for instance here, it'll graph the first piece fine, and then you'll get an error when it starts to graph the second. See, it graphs the first, and then you get an error because it can't graph the second because you have a syntax error in the second piece. Okay, so you can kind of tell where your error is happening. Okay, so that is that graph. I think I copied it. Let me see if I can paste it here. All right, so double check your graph that you did by hand yesterday. Okay, it should look like this. I'm going to add in my open and closed circles. Y'all can tell me where those should be. Okay, so on the pink portion, on the quadratic piece, should the endpoint be open or closed? Open here. It does not have or equal. and it goes on, so that would be an arrow. Okay, what about on that green piece here? What should the endpoints be? Closed. Both of them are included. Both of them have an or equal. Okay, and what about on the blue absolute value piece? Open on this left end and then an arrow here. Okay, so that's what your graph should have looked like when you did that. Any questions about that? So that's the green piece, the pink piece, and the blue piece. All right, now evaluating. You can evaluate using this graph or using the equation. So when you go to evaluate, what you do, step one, we put this in the little quick notes when we did that exploration yesterday, I think it was. We said first step is figure out what domain this input belongs in. So there are 3 domains here, the pink, green, and the blue. Which domain does -6 fall into? The pink. Yeah, -6 is less than -5. So then that gets plugged in to that equation and that equation only. We don't need the rest of it for this problem. So I plug that in and I say, okay, so this is -6 plus 6 squared. So that comes out to 0 squared, that's 0. If you want to use the graph, you can do the same thing. You look on the graph where the input is -6. So I go to -6. And how about that? I'm right there at 0. I would have gotten the same answer using the graph. Okay, but your graph has to be accurate for you really to be able to use it to evaluate. H of 0, where does 0 fall? Which domain? Yeah, it's in between -5 and 2. So this one falls in the green domain. This one's really easy to use the graph on because where is the function when x is 0? Oh, it's up here at 7. And you get 7 using the equation also. Okay, and then what domain does 2 fall into? Second or third? They both have 2. Which one would it be? The second, because that's where the or, if it's exactly 2, needs to be on the or equal to 2. Okay, and if I were to look at my table, or my graph here, when I go to 2, it's an open circle here, so that's not it. It's this one up here. So it is also 7. What if, it doesn't have this, but what if, because you're going to get a Delta Math practice assignment for a grade, and some of them might appear where, what if both of these did not have or equal? What if neither one was equal to 2? And you were asked to evaluate the function at 2. What would the answer be? It'd be undefined. It just doesn't exist. That means both of these would have been open circles and the function just doesn't exist there. There's a gap in the domain. Okay, so that's possible. You would just say undefined or does not exist. If it's in Delta Math, you can view an example and see what formatting they prefer. Okay, but there is this, the rest of this practice we'll look at it tomorrow. You can try the matching of graphs. I think you should be able to do that. And then there's some more practice evaluating at the end that you can try. That's not going to be due. It's just extra practice for you to make sure you understand how to do that. What is for a grade, what you do need to do is the Delta Math. And it's active. Today is Wednesday, so it will be due Friday. But like I told you before, when something's going to be due on a Friday night, I'm not going to grade it over the weekend. And you don't have school Monday, so that's actually not going to be due till Monday night by midnight, because I'm not going to look at it to put grades in until Tuesday. All right. I'll see y'all tomorrow.
I'll be out tomorrow as well for the
Okay. Thanks.
The notes for tomorrow, do you already have those? Like,
I don't have them ready to go. Sorry. I'll post them on It's Learning though.